Good morning, everybody. Thank you so much for joining us today. I am going to go over a couple quick notes before we get started. We are going to be recording today's session. We will email you after the session is over with a little bit of information from the session today, and you are welcome to request that recording. We can send a link out to you, or the slides will also be available to you. We also have the Q&A available today. We're going to go through the presentation without stopping. However, we will leave time at the end of the presentation to do the Q&A. So feel free to type the questions in there as you have them throughout the presentation. And at the end, we'll make time if there are any questions to go over those. That being said, thank you so much for joining us today. We really appreciate it. You've joined us for Beyond Trust but Verify, the journey to zero trust. So New Era software provides a comprehensive set of products, and they can help you monitor the operational readiness and integrity of your environment. And with this, they provide a consistent method of reporting and documenting things that might be required to meet or exceed the many regulations and guidelines in zero trust. And to go over this in more detail, I would love to pass this off to Glennon Bagsby.
All right, thank you, Sammy. And thank you, everyone, for attending today. As Sammy said, we're going to go through this. It's going to take about 40 or 45 minutes. And I appreciate you coming out and spending the time with us. We put together this presentation primarily because we've got a lot of feedback from our customers around the globe about increased pressure that they're getting from the auditors and the regulations that are being presented to them. And they wanted to know more about how they could use our existing products to meet some of those requirements. And we do have quite a bit of capability within our product offering. So what I wanted to do and what I've done is gone ahead and put together some samples of, of items we produce through the various products we present. We do this a couple different ways, but the idea is to address those requirements. Now, we all know that the regulations and the guidelines out there were put in place to help us protect the integrity and security of our business systems running on the Z mainframe. And so that's where we've been for 35 years. New Era Software has been in the business of helping you protect that readiness and that integrity for your mainframe environment for all that time, starting with a little recovery product and going from there to a more extensive, complete product line of capabilities that I'm going to point out to you. This is not going to be a regular demonstration of a particular product. This is going to be a quick overview and samples of the capabilities so that you can see them and understand how we might be able to help you stay current with those regulations, easily produce the reports and the logs that are necessary in order to document that compliance, and at the same time, understand any risk or problems that may exist within your environment. One of the things that we're going to point out is also we've started down a path of incorporating AI capabilities into the analytics of the data we produce, and I'll point that out as we go through this as well. So understanding that what we're talking about here is protecting an environment where we're running our businesses. We're going to have different items that the regulations target. Some of the regulations are more focused on the data. What's encrypted? How should it be encrypted? What's the retention period? How do we transfer that data? All of those kind of things are what the target of regulations and guidelines are. Others, for example, like DORA, looks more at the things that execute, the programs, the routines, the different applications and the application capabilities that actually executes and builds that data or processes that data. And they want to know about if that's secure. And so they focus more on that area. We, on the other hand, focus more on the operational system, the ZOS environment, and understanding its risk requirements and the ability to protect that environment. Now, we know there's no division between these. They flow back and forth, up and down through this reverse pyramid. So there is no division necessarily. So we all look at all of this. but there are different focuses and different intentions that the guidelines are at. And so we're going to talk about primarily at the operating system level, some at the executable level as well, not so much on the data. The data is special because of the volume of the data that you have to manage, and that's pretty well covered by regulations and processes that you probably already have in place. So one of the things that we have to worry about when we're talking about integrity and availability of the ZOS environment is how secure is it? I'm sure all of you use the external security manager, RACF, ACF2, or Top Secret to provide as much protection as you can against the different resources and configurations and things that go on and have to be managed within that environment. This includes certificates and all the other associative things that go on with setting up that environment and protecting it. And it has to be there. It has to be as complete as you can get it and make sure it's constantly being maintained and taken care of. That's growing as well. It's becoming an increased cost factor, an increased staffing issue to have the right people in to take care of the external security managers and maintain all the items and things that need to be controlled. And certificates in particular have gotten a lot of attention recently and will continue to do so with the renewal schedules and things like that. And we have applications that can help you with those things as well. I'm not going to touch on that too much today, other than to tell you that if you want to find out more about how we can help you manage your certificate environment, there are two webcasts next week that deal just with that topic, and I invite you to come out. I think you're probably on the same mailing list and got invited to that. But what we're going to talk about is something that I've talked about before, and I put up a quote here from Barry Schrager. It's an old quote. It's been around for a long time. I like it. I've used it several times in my other presentations because I think it's right on. And that's the idea is that you have to have operational integrity if you want to have security. If there's something wrong in your configured definitions and your Parliament members that open up an exposure, that's going to trump or overwrite anything else you do in other areas potentially. Think about the APF list. If you have an exposure in the APF list and it allows an authorized program to come in and do whatever it wants to do, it doesn't matter what you're doing with your executables because it's above that and it's doing things that you don't want it to do. So you have to have that integrity at the configuration level for the operating system. And Barry knew that years ago when he put out that quote when he was building what's now ACF2. That's where we're at. We deal a lot with that configuration definition. So a lot of the examples I'm going to show you today deal with those statements, the ParmLab members, the data sets, the files, the load libraries, the linked list, LPA, those kind of.
No, nothing uses TMPDB.
Okay, those kind of things that we need to worry about and make sure this environment is secure. So let's just go on. Now, the way we do this, and some of you looking at the list of attendees are customers of ours, so you're familiar with some of these things I'm going to talk about, but maybe not all, because there's a lot of capability within our products that maybe not be exploited by you. So I'm going to touch on a lot of different areas very quickly, and I'll take questions at the end, or we can arrange a follow-on webcast to get down in more detail on any one of these. But the soul or the heart of what we do is produce something we call an inspection log. What this is basically the ability to virtually analyze the components that define a sysplex, an LPAR, a subsystem, or an individual ParmLab member, and to process them as if they're being used at either IPL time or when they're being called, and understand whether or not they're correct, complete, and what is their status? How do they fit in? Are we they're using the right symbols? Are they being processed correctly? Is there something different in them? Have they been changed since some prior point in time? And document that all for you within these inspection logs. These logs are very comprehensive and complete. So if you're not familiar with them, I've got a couple examples that I'll point out about them as we go forward here. But the logs can be produced through this inspection process in a variety of ways. They can be set up in what we call the production environment, which is basically a time-driven process or a sample driven, if you will, that will run these inspections on a predetermined interval, analyze the componentry that's been directed against, and tell us whether what we find is good or if there's a problem with it or has it been modified, and then appropriately store more information or send notifications or whatever it's been directed to do. The same process can be invoked interactively through what we call the workbench. So as you're beginning to ask questions about, well, I just modified a ParmLab member. Did I get it right? Can I test it before I commit that to the production environment? And the answer is yes, I can do that interactively through the workbench. I can also use the batch process to automate the monitoring as well and give me the same evaluation and to interact with the inspection logs in a variety of ways to help analyze and document and understand the environment. We also integrate into the IBM Health Checker for ZOS, and it gives you the ability to run an inventory of checks that we provide to supplement the checks that are available either from IBM or from other vendors. Many of these are totally unique and only available from us. Others may be a little bit complementary or even redundant to some of the other checks, but you'll see as we go forward here that we're not talking about simply syntax checking, parsing and syntax checking. What we're talking about is really the full evaluation of those configuration statements by any one of these inspection points, creating out the log. So this is just beginning to go through some of the screenshots that I grabbed, and I want to just explain it to you in this way. This is looking at a view through the workbench view, and I ask it to show me a sysplex that I want to inspect. I want to know whether or not this sysplex and all of its LPARs, in this case 5, are okay. Are there any problems, any risk, any issues within that construction of this sysplex and in each one of those individual 5 LPARs? You can see from the results that it found errors in all 5 of them. So I've been testing and playing around and forcing these errors. But what it's doing for me is giving me a very quick view of what the status is of those LPARs. If they had run cleanly, it would have said okay or success on the side. So that's telling me in this example that the sysplex will come together okay, but each one of these LPARs have a unique problem, and I need to deal with those problems. And obviously the log is going to give me all the detail I need to go research and correct those issues. Those inspection requests are built through panels, in this case through the workbench, but it can also be defined through JCL if you're running batch, or in the monitor, we take one of these predetermined requests and store those away for the interval timer on the production view to execute. You can see from this that you have control over the start point of the inspection. Now, the way that this initially starts is it will discover all the active LPARs within the sysplex you're directing it to. It will determine the IP address and load parm for you and all the other important values, but you can modify that. You can create your own and actually ask it to inspect configurations that have never been IPL'd before, that you know may not be complete, but you want to test them to a certain level. There's different controls you can set when you run these inspections. And not only the IP address and load parm values, but also other important items. Now, if you look at the screen near the bottom, there's a field in here called Secure Boot. I wanted to point that out because here at New Era, we have an application that if you haven't already started to research or implement Secure Boot, sometimes called Validated Boot, that ends up in a list-directed IPL structure, we have an application that helps you do that. If you've gone that far and you have a secure boot or list-directed IPL that's been set up, we can inspect that in the same way we would inspect all the other components that define that LPAR. In other words, testing whether or not all the signing is acceptable and correct, and so that the secure boot will operate correctly. So if you haven't gone that way, talk to us and see if you are interested in seeing the application. We can help you automate that process. But if you haven't gone that route, just be aware that we can test and inspect that environment as well. Other things we can do is just below that, there's a yellow area called Staged ParmLab. This is one of the many options you can apply to the inspection where you can insert staged changes or planned changes in order to test them before you commit those to the actual running process. And at the bottom of the screen, these are the different environments that you would like to be included in this inspection request. And that will give us the results that we expect to see in the log. Now, the log will be produced and create out a very comprehensive set of analysis across the full spectrums of whatever you ask it to inspect. And you can see from the list that I just put up, it does not only the operating system, but also the critical subsystems like JES and BTAM, TCP/IP, and all of its subcomponents. And it gives you the ability to certify all of those as being complete, correct, error-free, and will give you the results that you expect. So now we're digging down a little bit more deeper into that log that's being produced. And what you're going to see is as we progress down further, that we're actually going to use this information to build the documentation that's required to validate the status or the availability of certain capabilities defined to the operating system environment, and at the same time, build history and understand change activity, give you change points, give you versions of the different components, and give you the ability to not only compare across time those different elements or the different versions, but also restore if required as well. So some of the important ones on this list, you can probably pick them out. Things like the pageant, the policy agent, whether or not that's configured properly. That's certainly an item that is going to be interesting from an audit or a compliance standpoint. But also things like serve-off settings and getting into things like ICSF. These are all things that can be inspected, documented by our inspection process on each individual LPAR within each individual sysplex and give you the evaluation and understand the environment and tell you what's going on. Now, from that list, we can select one of them. So in this case, I would have selected the OPSIS, and now I have all the ParmLab members that exist in this particular inspection run. So this would be my different members. The BPXPR member you can see is a warning in it at the top. The PROG members have notices in them. All the rest came out clean. But again, what I have is an analysis of this structure. I have a complete document that tells me exactly how this configuration is built and how this instance of ZOS is created within the sysplex and whether or not it will all work properly and cooperate with the other LPARs within the plex. And again, by selecting one of the items, I can go in and look at the individual analysis that was done. So in this case, I selected one of the PROG members and it shows me the content. And certainly the syntax is checked. That's the first thing it's going to do. It's going to validate syntactically, do I have everything correct? And if it's wrong, it's going to tell me. But it's also going to validate the referential integrity of those statements. So you can see at the very bottom of the screen, there are some notice messages that came out that said you've got some data sets named in this APF list that don't exist. And that's part of the risk. That's something we need to deal with because that's an exposure from a security standpoint, obviously. But that's what we're trying to do with this log is to give you a complete picture of what would be processed, whether or not that item that would be processed at IPL time or at execution time, is it complete? Is it accurate? Can I trust it? Are there any underlying problems or risks that need to be dealt with? And tell me about them and document them, and then also store them away for comparison and history. And we have all that capability built in. That includes not only traditional MVS formatted data sets, but also Unix files as well, if they're in use, or BPXPRM, or for the policy agent, the definitions, however you're using it. We also support all of that and understand all the rules for syntax, all the processing rules, do all the validation of the content of the members that we inspect them. So it's very important to remember that we're giving you a complete picture of what that system looks like, member by member, data set or library by data set. But we also take it a little bit further again. What we're going to do is not only show you by member what we found, but we're going to begin to pull together a collection of the items identified in each of those members. So for this example, I chose the APF list again. So even though we had 3 different PROG members that could specify and have specified APF authorized data sets, We're now to combine them and create one list. And this list gives it to me alphabetically. I can see that list. It tells me whether or not they're missing or if there's a problem with that. You can see under the no DSN column that I have a couple of data sets of reference from some of the members that don't really exist. And that's the problem we saw before. The data set names don't match because I pulled these from different systems, but the idea being the same is now I have a consolidated list of a particular entry, whether it be APF or linked list or LPA or BPX PRM parameters or whatever the entity is that we combine together. This is also created as a reference point. So independent of the content of the members that are being checked for changes, we're also looking at the consolidation lists and tell you whether or not the lists have changed over time. So what's important about this is even though these data sets say they don't exist, if I were to go back and add this now, I would see the change to the member, but I'd also see the change to this particular report section as well within the log. Now we take these logs and we make them available in several different ways. We can do that obviously through a 3270 browse and search kind of an interface that I was showing you, but we also have a web-based interface into it. Now, what this allows us to do is to do more analysis for you automatically. So in this case, I'm using the APF example again. And what it's showing me is in this case, my 3 LPAR, 3 of the 5 that I've asked it to tell me about, up to 10, or if I have more than 10, I have another screen or more screens out there behind it. But what it's doing is painting a picture for me of what do the APF lists look like across LPARs. So you can see in this example on line 3, I've got an APF authorized data set that's available on LPAR 1, but it's not available on LPAR 2 or 3. So very quickly, I can do the analysis and tell you whether or not all of my LPARs have the exact same population of a resource. In this case, it's APF, but the other resources track the same way. Now, if I had to do this manually, and I'm doing it for 10 different LPARs and try to figure that out, it's a task that's going to take some effort. It's going to take some time and take some work in order to paint this picture. We can do it for you with a click of a couple buttons. That's the idea of this, is that once these logs are created and the data sets that contain all of the information about the environments, their status, their definitions, their inventory, if you will, of componentry, we can now use that to give you more concise, accurate pictures of those environments so that it's not something you have to spend a lot of time and research on to figure out. That's the purpose of this, is to give you the ability to get maximum value from those inspection logs that can run independently on a timer or in batch, create out the records you need within the log, and then have the analysis done for you and present the results very effectively, very cleanly in different views. And this is just one of several ways that we can present this information to you. Then we get into, okay, tell me about changes that have happened in my environment. So picking on the APF again, because it's easy to do. Here's this example where I've added a APF authorized data set to one of the PROG members. In this case, it's PROG CM. The top is that APF report I showed you. And it would come back and say, hey, we ran this again, and I noticed that this report has changed. There's been a new line added in it, and so that data set has been added to that particular consolidated report that I showed you before. At the bottom of this, the bottom window is actually the report that was generated out about the change to the member itself. So we actually have this reported twice. Once in the member that was changed, and so we have idea about that. And by the way, we capture our statistics and a whole bunch of other potential information about that change. But it's also modified that log. So if anything changes anywhere in any of those two data sources produced by the inspection, we have records of that. This is written into our own data structure, and it's easily able to be reported on and documented and sent out to whoever needs to know it on whatever interval you want it reported on. You also have control over how much history we keep. into different blueprints or packages that we build, or baselines, however you want to think about this. But the idea is we're going to do that for you automatically. So if you need a report, you push a button or two and you get the answer. This is again an example of looking at the history of changes for a particular member within a particular data set. Show me all the times that we've seen a change, or someone's tried to make a change. That's an attempt in the second column. And any one of these or all of these are fully documented. So if I click on any one of them, I could go get the full history and documentation of that. So the idea here again is to keep the information from the log usable and valuable, because it's being produced not only at each interval that it executes, but the history can be extracted out of it and stored as well, and used in different ways. Again, tracking for changes is one of them. Now, when we talk about changes and change tracking, you have simple edit things. That's the things I showed you before, that you would go and make a change to a member and save it, and then it's there, it's committed. But we also have dynamic change capability. We know that within the environment. We have the ability to capture changes issued through the console if you want to do that. If you're not already have a method for seeing the actual commands and recording them, if someone does a set prog or a set APF, we can track those things for you as well and record those in our history files. But in this case, what we want to do is ask the system to tell us, has anything been changed dynamically that has not been confirmed or hardened back into the appropriate members within the data sets that configure this particular system? So it basically does an audit of running the running system values against the definition members for the same LPAR and tells us whether or not there's an out of balance. So in this case, you see, again, picking on APF, that there is a difference in the APF list, that the running system is looking for a different system than what's defined in the members. And that's the super compare output we have in the lower screen. That's what we're talking about here, having a tool that with a simple question, asking it either through a command or through the VTM application in the workbench, give you back this answer and tell you right away that you have a situation that if you take an IPL right now, you're going to lose some of the things that were changed dynamically because the update wasn't completed and hardened or committed back to the different Parmlab members. And you can see the different environments that we include in that, not just APF, though I keep picking on that, but BPX PRM members, linked list, LPA, these are all can be checked and confirmed that way. So those are kind of the configuration members, right? These are things we're worrying about setting up the environment and building the environment properly. But now if we start moving up that reverse pyramid that I had, we start talking about things that execute, things that are going to manage the data, or services from the operating system, or programs that have been written to process that stuff. And some of that is defined in Parmlab members as well. And so now I'm looking at the schedule member and the program property table. So just like we looked at the pre-ROG members or the other members that were on the list, we're going to do the same thing for the schedule member and tell us about the program property table and tell us, is it right, or is there anything wrong syntactically? Is there any references in here that don't resolve properly? Or has it been changed since some prior point in time? And we're going to do that again, member by member, but we're also going to do that in a collage or a collection of all of the statements that build the program property table. And we can do that again in a 3270-like session, looking at a report like this, or we can do it again in a browser session in the Windows that I showed you before. More real estate, more clarity, and additional analytics that would show up within the different displays within the browser environment. But the intent is the same. Tell me about this important element of the configuration and whether or not I can trust it. Is it complete? Is it going to give me what I want? But when we're talking about programs, we have to go beyond that. We have to start asking the questions about, is that information going to give me the definition information that's out there, going to give me the results I expect? So part of the inspection process is you have the ability to ask it to check the authorization level of the different programs. In this case, it's kind of an unusual one, but it's one that was easily set up to show you, is we wanted to see whether or not a certain program, in this case, the JES startup, would possibly advent with a System 47 because it lost APF authorization. So you can actually ask the inspection process to get to that level of detail in its inspection for the executables to tell you not only if they've changed or anything about their running parameters have changed, but what effect those changes may have on the execution of that particular program or that particular module. So that's what we're talking about here. It's getting down to a much lower level and understanding the effect and building the history of changes and telling us about those. Now we're talking about executable things, and we have to talk about load libraries. And we have to be able to analyze load libraries as well. So we have capability within the inspection process identified separately just to manage load libraries or alternate member data sets. But in this case, we're looking at load libraries. And what we wanted to do is ask it to inspect a collection of load libraries. These could be automatically built from things like the linked list or the LPA list or the APF list, or it could be a list that is generated by you. Give me a list of data sets that might be my Broadcom load libraries or BMC load libraries, and I want you to monitor them. And you can see from the indexing what it's going to look for is, do we have any duplicates in the concatenation set? Have there been any changes to any of the load libraries or load modules that exist in there? Or do I have any orphaned aliases anywhere within that concatenation set? So now what it's going to do for me is do that level of analysis. It's going to go look at the list, and the top one we're looking at linked lists, and as we're asking the question, are there any orphaned aliases within the inventory of the load libraries within the linked list? And this will detect that. It will find them automatically and give you back a very exact list and a clear picture of what you have in the linked list if any of those modules are orphaned, either by the parent or by size or TTR or some other reason why they're being orphaned. It will tell you all those things. It will also go through and tell you if I have duplicates within the list. And you can see in the bottom window that indeed linked list in this case has 690 modules that are redundant or duplicate within the load libraries named within linked list. This is typical, by the way, but it's something that really should not be. It can cause confusions and problems. And again, this information can be stored away as a baseline or a blueprint in order to know whether or not any of these values changed. And so here's an example of a change document that comes out that says, well, linked list actually has been changed. There's been 3 modules added. Okay. There's been a couple change, one change by size, one change by TTR. So the idea again here is to give you a very quick auditable source that will give you clarity and information about your load libraries in these lists and tell you whether or not there's been changes and what changes have been made, or if there's issues and problems with them. If you think about if you had to do this manually, if you had to go through all the load libraries and linked lists and determine whether or not there were any duplicates on your own, the effort it would take to try to do that. This does it again with a click or with a command, and it will go off and give you these kind of reports. And you can run these reports whenever you choose to. Something like this, you probably wouldn't want to run every day, but maybe once a week or once a month or every 6 months or some kind of a pattern to let you know that you're under control or these items are under control and you're aware of the changes. So if this is something that was a finding that you didn't have control over this, or someone asked the questions and you need to produce a document that says this is the same as it was when you last did the audit, you can do those things very easily with using the applications that we provide here at New Era. Now, changes happen. We make changes whenever they're required, right? Sometimes every day, sometimes only on emergencies, but changes do have to happen. And you build new systems and you put them up, and you need to know whether or not they're going to be usable and compare them one image to another. You can do that very easily with all the information we create in the logs. You can create a total blueprint for a configuration at, for example, 2.5 and then you build up a 3.1 system and you want to compare 2.5 to 3.1 or 3.2, you can do that very easily by using these logs. And that's the idea of that. But when changes are required, we need to be able to understand and document those changes as well. So in this example, when I showed you before where I added that particular data set to the PROG member, there was a process invoked that said, we need to capture that event. Now, the processes of inspection by image focus application will and did detect that whenever the interval came around or whenever I ran the inspection. But that's not good enough. I want to know immediately if that change was made. And that's what this other application called the control editor does. It sees the event as it occurs against any of the critical data sets, either automatically picked up in the IPL structure or it's defined by you. It will record that event into our own journaling system. It has immediate response, immediately write this out. It sends off auxiliary information like emails that go to groups and all kinds of other things that it can trigger. One of those is the documentation interface that says when you make a change to this particular component, here's a document that you are required to fill out. And so I put that up in the window here as well. That's the document that I chose to use. It's a default one that we send out, but it's an ISPF panel. You can design your own, do whatever you want with it. What's important about this is, as I said, this is immediate action when this occurred. We're not waiting for some post-processing of SMF records and dig through the millions of records to try to find it. We're not waiting for another compare to execute to look for this. It's immediate, known, and we're going to act appropriately at the point in time when that change is attempted to be made. That change can also at this point be immediately inspected. So I could check the syntax and the referential integrity of that change while I'm still in my edit window without having saved it yet. So I'm not saving something that's wrong, or it'll direct me to what I need to do the improvement. So by putting all this together now, I have a control over the edit event as well as a record of that edit event. And it will also be captured by the inspection, added to the log, so I have an auditable point of it within the full structure. So this is the record that we would see in our journaling file. And it has the ability to store all the change events across a full list of critical resources and create all the history and documentation for that. It has its own reporting systems. It has its own query capability. It can do all kinds of reporting and documentation for you into those pictures I showed you before on the web browser or in 3270 kind of world. But the idea is this information is immediately captured when the event occurs, written to its own data source, and provide auxiliary services like email notification and other unique reporting that you might want to trigger. Now, I mentioned at the very beginning that we could do these inspections in a lot of different ways. We run them either in a 3270 kind of session, that's a VTAM application. They can run in batch. They can run in what the monitor mode we call background. They can run inside the health checker for ZOS. This is a list of the checks that we provide that would run inside the health checker and give you the individual characteristics or testing of each of these groups. These are broken down into individual checks so that you can identify an area that you would like to be monitored. This runs under the control of the health checker. So it sets the interval, the execution cycle. It writes information back to the health checker, acts appropriately like any other check in terms of telling if you have high or medium or low severity issues. And it gives you the full capability to turn this monitoring on inside the health checker. So if the health checker is the environment that you standardize your alert system to, we integrate properly and completely into that. But one of the things that we've done is brought up something new. Now, if you're paying attention, you'll notice that the background changed. I did that on purpose. I left this exciting background here for this because what we're talking about now is that introduction of using AI capability into processing the log data. So IPL check, as some of you may know it as, has been replaced with an application now called IPL check AI. The analysis of the logs have been greatly enhanced using AI capability, as well as the extraction logic that's used by the checks. It now has got strength in it, and it does a lot more work in collecting information to put into its logs. The analysis basically looks at a log in a normal ISPF or TSO environment. You don't have to go to another VTM application. You can stay directly in TSO ISPF and bring up these sample panels. These are, if you will, uh, summarization in one case of what we found within the log. These are also entry point panels to let you look at things. It consolidates kind of a dashboard theory to you. So just real quick, what we're talking about is give me the status of the system. That's the one on the left that's been monitoring and looking at the log and analyzing it for you, telling you where the concerns and the risk and problems are, let you point and click or go down to the data or the detail very quickly through that panel. We have more of a higher level dash view in the center where it's going to color code things like changes or warnings and errors. It has compare capability in it, has a lot of functionality. And then we can begin to pull together a collage of logs from different LPARs and put them together into a multiplex view. So we can actually look for LPARs across graphically dispersed systems. Pull in an LPAR from Hong Kong or one from South Africa and compare it to one that's running in Mexico City or in Dublin. Give you all that capability to look at that to make sure that there's a standard established, that the standard exists, that there's no drift in any of those remote locations, and it's running exactly the way you want. So the AI component is very important here, and we have a separate webcast just concentrating on that to make sure that we're able to show you completely and correctly how we've introduced the AI capabilities into the analytics of the logs themselves. So that's something to pay attention to as well. But now we're back to this inverted pyramid, the ability to go up and down through the structure between the operating system and executable code to understand the configuration definitions and to make sure that we are aware of activity and events that may affect their availability and affect the auditability of those. But I talked about the control boundaries, and that's really where zero trust comes in. And I know we talked about zero trust at the very beginning of this, but it's really to summarize what all we're doing here. Now, a major part of zero trust has not only about how you protect those definition elements that we went through, but also access to the system. We talked about using the security systems to do access control. There's weaknesses within that, and I think you probably understand and know what those weaknesses are, and we try to overcome them as best we can, given the restrictions of RAC FA CF2 or top secret. But part of the zero trust foundational concept is that we need to understand that there's risk, and we need to understand that risk as a result of the network being compromised. And when they were talking about compromise, they're talking about someone who logs in with valid credentials and either has got a hold of those and logged in as, even though they're not the right person, they've got that person's credentials, or someone is trying to exceed their authority or their responsibility and getting into areas that they should not be into. So that's what zero trust is about. How do we establish the identity and the trust for that person making that request? And there's all kinds of things within here that deal with that and talk about it. But one of the things that they point out is very important when you talk about this is a very simple concept that they lay out, which we're all familiar with. And that is someone who's sitting behind a screen, logging onto TSO ISPF or some application, and being permitted access to a set of resources and commands by the external security manager. And that's typically how it's invoked and how we're doing things. But zero trust says, wait a minute, that's not good enough. We need to understand that if we're assuming that the credentials of the person behind the screen have been compromised and it's not really that person, or that person is trying to do something that they're not supposed to, then we need to be able to understand that what's going on the right side of the screen is appropriately defined to that person and understand unusual behavior or something that's going on that should be a problem and stop. And that's what they call dependency mapping. That is saying this person who logged on has a universe of data sets and resources and commands that they can do. And if they attempt something that's not within their universe, we need to be able to recognize that quickly and shut it down. The other part of this is how do we confirm the identity of that person sitting behind the screen using that identity? And in Zero Trust, they call that excessive access checking. And what they're saying is, how do I verify the identity of that person sitting behind the screen? Now, we all have multi-factor authentication and all that stuff, but again, the assumption is all that has been compromised. So what they're introducing is something that we're familiar with, probably, and it's simply called something called sophisticated verification. Sophisticated verification exceeds what you have with a password and even MFA. What it's saying is we need to be able to implement things that we're used to when we deal with transactions, usually on the web, with our bank or insurance companies or whatever, where we have pre-stored an answer to a question that could be asked. You log on to your bank and you say, "Oh, I lost my ATM card. Please send me another one." The first thing you're going to say is, prove to me that you are who you say you are. Give me what year were you born in? What was the color of your first car? What's the name of your pet? These are all things that you answered ahead of time and stored the answer away so that it has a way of verifying that it's really you making that request. So as you go up if you will, the risk scale, they can invoke that extra challenge, that extra ability to, okay, I see you've logged on and you got the right credentials so far, but now you're trying to do a little bit more than usual, or you're trying to get into a real sensitive area. I'm going to ask you to verify that you're really who you are. And we have the ability to let you implement that strategy on the mainframe. RACF, ACF2, and Top Secret don't provide that capability at all. But what we're going to do is allow you to say, we're going to allow an individual user to store away private PIN. That's something that only the user knows, and it's encrypted and stored in our system. Then whenever they reach that point where we want to challenge for the identity of that person, we're going to do it in a way where we're going to combine what that person has stored versus what the external security manager can provide. So we're going to invoke it again, and we're going to say, give me a pass token, give me a value generated by the security system. And I'm going to break that into two pieces. I'm going to send one piece back to the requester sitting behind the screen, and that can be done by email or text message or some other method where we get that information to that person behind the screen and say, all right, here's my part of this. Give me the part that you stored. And by combining those two together, we will know it's you and we will let you pass through. If you don't give me the correct value, you're not getting in. You're not going to be able to do what you're asking to do. So what we're able to do is to meet the requirements of Zero Trust to do this excessive access checking, to verify the identity of the person sitting behind the screen, because again, the assumption is those credentials have been compromised, or they're going after something that they're not supposed to be, and they're acting like somebody else. And so there's something that we need to do in order to do that. And that's what we do with our application inside the control editor to add that capability. And this is, again, it's something we can set up a more detailed demonstration and explanation of what we're doing. So now just kind of move into summary. This is going back to the very first slide to talk about, again, what we're trying to do is show you that there's a lot of value in the logs that we produce from our inspections that lets you create automatically the reports that need to be generated out, the change notifications, the pictures, the images, the status of all the critical resources whenever they need to be, and be able to automatically notify you of things that that are out of bounds or changes. So you can produce those very quickly and easily without a whole lot of effort or man time and loss of serviceability, if you will, and do it all uh, using the logs produced by us. So that's the idea. And then we talked about adding the AI component. There'll be more coming for that in the coming months. So keep tuned and you'll see more from us about that. And you'll also see some changes about how we're going to integrate through a native TSO ISPF environment instead of from a VTAM application and the web application. So again, we have a full set of comprehensive products that help you stay in compliance, meet the requirements all the time. If you have an audit coming up or if a finding you need to deal with, turn to us and see if we can help you produce that. Come back out and ask for a follow-on session and we get into much more detail about it. Here's some contact information on the bottom to get a hold of our support team or our marketing group, and we can set up those other additional briefings for you in detail, or my information is at the bottom of the screen as well. So thank you for your attention. I appreciate it. I will take any questions if you have any right now. Please, do they need to write them or can?
Yeah, if there are any questions, go ahead and put them into the Q&A. I don't have any right now. We'll give you a minute to put them in. And if it is something you didn't want to talk to online, you can contact that info@newera.com with any questions that you have. We can reply to you directly as well. If no questions are coming in, I just want to thank you, Glenn, and thank you everyone who joined us today. We, as Glenn mentioned, have a few more webinars coming up through this month and would love everyone to join us for those as well. If you would like to do a one-on-one client briefing, we're available for that as well. We can see how this fits into your environment directly. One more time, thank you all for joining us today and have a good one.
Bye, everybody. Thank you.